Good morning, everybody. Good morning, Section D. So, allow me to start the discussion so that we could finish early before lunchtime. Okay, so for this morning's discussion, we will discuss still drawing Lewis formulas of species, may it be molecules, ions, but this time you will observe that the Lewis structures of the species are exceptions to the octet. If you recall, when we discuss the basic steps in writing Lewis formula, we have drawn different examples, and most of the examples that have been drawn, the atoms in that molecular ion, they attain octet, meaning 8 surrounding electrons in that atom, or for hydrogen, 2 surrounding electrons for hydrogen. Now, this time, please always take note also that there are also few exceptions to that octet rule. Particularly, the exceptions are applicable to those atoms that are found in the period 3 of the periodic table. Okay, most of the encountered molecules or ions that octet rule is not applicable to them, the central atom are found in the period 3. Okay, majority found in the period 3. But there are also example phosphorus as the central atom or sulfur as the central atom, or other non-metals being a central atom found in the period 3 or higher or below it, pwede silang exception to the octet. Okay. There are also na yung central atom like boron and beryllium, kapag sila yung central atom in that molecule, they also do not attain octet, but they are still on the stable binding state. Sige, let's try to understand what are those examples of molecules that are exception to the octet. Okay, so number one, exception to the octet may occur in molecules with electron deficient atoms, or for those central atoms that have fewer than 8 electrons surrounding them. Okay? So, halimbawa, those gaseous molecules that contains beryllium or a boron as the central atom. Let's say, for instance, in the molecule beryllium chloride, of course, beryllium will be the central atom. In the molecule boron trifluoride, obviously, boron will be the central atom. Now, later, when we completely draw the Lewis structure of each molecule given, you can find out na the central atom is deficit with electron. Deficit because it's fewer than 8 electrons. So it did not attain octet. So let's try to draw the Lewis structure of these gaseous molecules. Let's start with beryllium chloride. Beryllium chloride, again, the central atom here would be the beryllium. And therefore, two of the surrounding atoms are the chlorine. What's the next step? If you place already the central and the surrounding electron, we total the valence electron. Recall that beryllium is part of group 2A element. So it would have two valence electron. Then chlorine being a halogen, it has 7 valence electron. So total of 7, 14, 15, 16 electrons. Okay. Then upon drawing single bonds, minus 4 electrons. And the remaining would be 12 electrons. So this 12 remaining electrons will be distributed to the surrounding by 6. Why by 6? Because the surrounding chlorine, they are lacking 6 electrons to attain octet. Now try to look at the central beryllium atom. You observe that the central beryllium did not attain here the octet. Okay, the central atom don't have enough electrons to attain octet. Okay, and we cannot apply here the fifth step just to attain beryllium's octet state. Why? Why we cannot apply here the fifth step? Because the surrounding are halogens. Remember, okay? Halogens, remember that halogens are stable already with one bond. And how many electron? With one bond and six lone electrons. That's the most stable binding state of halogens. So never will happen na yung halogen, surrounding halogen will give up their lone pairs and make it a bonding pair. Again, the most stable binding state of halogen, even when you try to check all the examples that you have drawn previously in your notes, lahat ng surrounding halogens, yung pinaka-stable number of bonds, diba nila, is only one, having six lone electrons. So meaning to say that is already the stable binding state of chlorines here. But let's try to check beryllium. Ma'am, si beryllium, it did not attain octet. It only has 4. It only contains 4 surrounding electrons. Now, we could confirm if having that 4 surrounding electrons, stable binding state na ba niyan ni beryllium. We can make use, apply formal charge rules, di ba? Ang formal charge, that will help us determine if the atom in that molecule is in its stable binding state. Now, let's check the formal charge of that beryllium. Formal charge again is again the number of valence electron of that atom. So this is per atom minus the lone electron. You add that to the number of bonds. Diba? That is the formula of formal charge. So when you try to substitute the values in determining the formal charge of beryllium, beryllium has how many valence electron again? 2, because it is part of group 2A. Group 2A in the periodic table, minus, it has lone pair? No. Wala naman siyang lone pair dito sa pag-draw nyo ng Lewis structure. So, 0. Meron ba siyang bonds? Yes, dalawa. So, 2 minus 2. Therefore, beryllium here will carry no charge. It will carry no charge, and meaning to say, kapag wala siyang charge, that is stable. Okay? At that state, that atom is in its stable binding state if it has no charge. Okay? And you can tell here nga, beryllium, although it is deficit with electron, it is still stable. It still attain its stable binding state. So this is exception to the octet. Kasi hindi naman 8 yung surrounding ni beryllium dito, 4 lang, but still stable siya. Let's have another example. Boron trifluoride. So boron will be the central atom here. Then the surroundings are fluorine, tatlong fluorine. And fluorine are again halogens. Fluorine is considered the most electronegative halogen. So boron, sige, let's have the total valence electron. Boron, part of group 3. Group 3 elements in the periodic table. So fluorine, 7 times 3, o ilan? 20. Okay, 24 electrons. So, yung 24 electrons, you have to subtract 6 electrons. Ilan na lang? 18 electrons. So, yung 18 electrons will be distributed by 6 to the surrounding fluorine. Okay? So, ubos yung 18 electrons. So, no problem with the surrounding fluorine. They all attain octet state. And that is the most stable number of bonds for halogen having one bond, 6 lone electron. Okay? Then, boron, as the central atom here, it only contains how many electrons? How many surrounding electrons for boron? There are 6 surrounding electrons. And that is not octet state. It's deficit from electron. But this is actually the most stable binding state of boron, having 3 covalent bonds surrounding it. we can check for its formal charge, kahit yung boron. Kasi alam naman natin na walang charge dito yung fluorine because they already attained their most stable number of bonds. Sige, let's have boron. Boron has 3 valence electron. Wala siyang lone electron. Tama? Puros raman yan, bonding pair. So, plus 3. So, 3 minus 3. Therefore, boron will carry no formal charge, and meaning to say, it is stable on this state. So, these are examples of electron deficient atoms. Okay? So, always take note, if beryllium and boron are the central atoms in that given molecule or ion, then expect that the central atom will be deficient from electron. So they are exception to the octet. Okay, let's have another example of exceptions, molecules that are exception to the octet. Okay, now another exceptions occur in those molecules with odd electron. Sorry, ayan. Odd electron atoms. Okay, now usually, by the way, when you say odd, I believe you know already this term kapag odd, di ba? Halimbawa, 1, 3, 5, ayan. 1, 3, 5, 7, 13, 17, yan. And usually, most commonly encountered, yung mga molecules having an odd electron atoms. It is being observed among those molecules containing a central atom that also carries an odd number valence electron. Halimbawa, di ba, nitrogen, meron siyang odd number of valence electron. I repeat, this is usually observed if the central atom also contains odd number of valence electron. Halimbawa, nitrogen, its valence electron is how many? How many valence electron again for nitrogen? Okay, there are, anybody? 3. Are you sure?
Five, five.
Okay, there are 5 valence electron for nitrogen. Okay, so it's an odd number. Alright? So again, most commonly encountered stable nga species which exist having odd number of electrons are those nitrogen oxides particularly. Okay? And usually when you encounter halimbawa nitrogen dioxide, so that is an example of nitrogen oxides. And again, it is expected na when you draw its Lewis structure, there is an odd electron. Meaning to say, kapag sinabing odd electron, meron talagang isa dyan na electron na walang partner. Kasi may odd electron. Di ba remember, when you distribute the electrons, it should be by pair. So when you say odd ang total electrons, there is an existence of an unpaired electron. And if there is an unpaired electron, we refer that species as a free radical. Okay? So take note, free radical ang tawag if that species, may it be an ion or a molecule, and then it contains a lone unpaired electron, contains lone unpaired electron, then that is considered free radicals. And one of the characteristics of free radicals is that they are very reactive in nature. They are very reactive in nature. Why they are very reactive? Common sense, merong walang partner. For them to attain stability, stable state, they need to react with another entity, with another species for them to attain stable state. Okay, that's why in nature, kapag free radical yan na species, meron siyang unpaired electron, very reactive talaga yan in nature. Okay, so let's have an example of a molecule having an odd electron atom. So we have nitrogen dioxide. So when we draw its Lewis structure, nitrogen will be the central atom and that two oxygens are surrounding. You tell me what's the total. Valence electron. 5 plus 6 times 2, total. Sige, yung total. It's an odd number, 17 electrons. The only present students are Torre and Sabado. Okay, I will check the attendance. It's actually automatically checked kapag Google Meeting. Okay, so it's an odd number, 17 electrons. So when you draw single bonds, so minus pa yan, minus 4 electrons. So another odd number yung remaining electrons, 13 electrons. What will you do to the 13 remaining electrons? Distribute it first on the surrounding oxygen by how many? By 6. Okay, by 6 kasi kinulang ng 6 yung surrounding oxygens. 6 by 6, so 6, 12. Meron pang isa. Saan ilalagay yung isa? Tingnan, yung central atom, meron siyang unpaired electron. And that makes it a free radical because it is an example of a molecule that contain unpaired electrons. Specifically, its central atom has unpaired electron. Okay? But we can, this is not yet the final Lewis structure because remember, uh, we can still apply the fifth step here because the surrounding are not halogens. No? So, pwede tayong mag-apply ng fifth step, making the surrounding lone pair into a bonding pair. Kasi hindi naman yan halogens, di ba, yung oxygen. And remember, oxygen's number of stable bonds, oxygen, stable number of bonds niya, 2 bonds. Okay? With 2 lone pairs. Okay? Very good. So, pwede pa, hindi pa to tapos, no? Hindi pa to yung final Lewis structure. Okay? So, para somehow ma-attain ng central nitrogen, yung pinakamalapit niyang stable state, you can make use of the fifth step, change the lone pair from the surrounding into a bonding pair. Pwede din ba sa kabilang oxygen, kumuha ng isang lone pair, changing that to a bonding pair? Yes, that's why it could produce another resonance structure. Hanggang dyan na lang yung hindi pwedeng isabay mo yung pagkuha ng lone pair sa magkabilang oxygen. Kasi at this state, di ba, nitrogen already contains 3 bonds. Ano sabi natin kay nitrogen? Your knowledge about nitrogen stable number of bonds is how many? 3. 'Di ba? You know that 3 bonds yung kay nitrogen. Okay? So, tama na yung isang Lewis structure na ito. Tama na yung Lewis structure na ito. So, you can produce another resonance. Pwedeng sa kabila yung double bond. Sa right side yung double bond. So, ibalik natin yung tiga-anim. Tiga-anim, di ba yun initially? Tiga-anim, yung oxygen. Then, merong isang lone electron, yung gitnang nitrogen. So, pwede din naman, applying the fifth step, on the right oxygen ka, kumuha ng isang lone pair, gagawin mo siyang bonding pair. Okay? Then, you check if stable ba yung binding state ng mga atoms na to using the formal charge rule. Okay? So you can start with the first structure. If this is structure 1, then this is structure 2. Let's start with nitrogen. Ano yung formal charge ng nitrogen? Parehas lang naman yung nitrogen sa structure 1 and structure 2. Merong tatlong bonds, merong isang lone pair. So kapag nakuha mo yung formal charge ng nitrogen sa structure 1, yun din yung equivalent formal charge, 'di ba, ng nitrogen sa structure 2. Okay, so nitrogen has 5 valence electron minus, meron siyang lone electron, isa. Okay? And then, meron ba siyang number of bonds? Yes, tatlo. So 5 minus 4, that's a positive 1. So both of the nitrogen, structure 1 and structure 2, they carry positive 1 charge. Question, yung oxygen ba sa structure 1 on the left, what do you think is the charge? Would it carry a charge or not? May charge or wala? by just looking at the structure. Yeah, the number of bonds ng oxygen, wala. Okay, remember that the stable number of bonds ng oxygen, dalawa yung bonds niya. Therefore, wag nyo nang sayangin yung oras sa pag-compute ng formal charge. Automatic, right there, no charge. So, 0, that is the most stable number of bonds ng oxygen. Whereas, oxygen na merong isang bond, na-draw na natin to previous meeting, kapag isa lang yung bond niya, it's a negative 1 for oxygen. Okay? So, kahit kunin nyo pa yung formal charge niya, ito, kahit you get or determine the formal charge in a step-by-step process, you will uh, get negative 1 charge for oxygen having one bond and 6 lone electrons. Okay? Then, as you can see, parehas lang sila ng mga number of formal charges, values of formal charges for structure 1 and for structure 2. 'Di ba? Merong nitrogen atom na nagke-carry ng positive 1 charge, meron namang isang oxygen na nagke-carry ng negative 1 charge. So question, which of the two structures is or are more contributor to the resonance hybrid? Okay, both. Equally contributor sila sa resonance hybrid. And what is your hint dito? 'Di ba kapag parehas lang yung surrounding atoms, automatic equally contributor sila sa resonance hybrid kapag parehas lang yung surrounding atoms ha. For resonance structures, they are all equally contributor to the resonance hybrid. Now, ma'am, how can we attain the stable state of nitrogen in this molecule of nitrogen dioxide? Of course, we would really conclude na having a lone electron, unpaired electron, hindi talaga stable ang nitrogen dyan. That makes it very reactive. So usually, kapag you encounter free radicals merong unpaired electron, ang mga free radicals, for them to attain their stable state, especially for the central atom, for them to attain stable state, kailangan nilang mag-react with each other. One molecule of nitrogen dioxide, another molecule of nitrogen dioxide, kailangan nilang mag-react with each other for the central atom to attain octet. So let me draw it. So halimbawa, okay. Let me draw it here. So let's say, draw ko ulit ha yung in this orientation na lang. So sabi natin kanina, yung central nitrogen, meron siyang isang double bond towards oxygen and then another single bond naman to a separate oxygen. Then merong isang lone unpaired electron yung nitrogen. So sabi ko kanina, for this central nitrogen to attain octet, or for any free radicals for them to attain, not octet, sorry for the term, to attain stability, no, stable state, for this nitrogen atom to attain stability. Okay, dapat ang mga free radicals tend to react with each other. Free radicals tend to react with each other. Okay? So para ma-attain ni nitrogen dyan, yung stable state niya, it would react to another nitrogen dioxide molecule. So let me do the other Lewis structure or resonance structure ng nitrogen dioxide. So let's say nasa baba naman yung double bond towards oxygen, then yung nasa taas yung single bond towards oxygen. So again, para ma-attain ng mga central nitrogen atoms na to yung stable state, they will just react. They will just react, forming a nitrogen single bond to a nitrogen. Ayan. So let me completely draw the structure. Ayan. Okay, so yung point lang dito is kapag free radicals for them, again, to attain their stable state para wala na yung lone unpaired electron. Para, kasi 'di ba they are very reactive. So they really would tend to react with another molecule na meron ding unpaired electron. So i-share nila yung meron silang unpaired electron para ma-attain yung stable state ng central nitrogen atom. And this is not already nitrogen dioxide but dinitrogen tetroxide. Kasi dalawa nitrogen, apat oxygen in this structure. So dinitrogen tetroxide na yan. And it has a stable structure, okay, especially for the central atom. Okay, sige, let's have another example na still exception to the octet under odd electron atoms. So let me erase this writings. Sige, let's have this nitrogen monoxide. Okay, nitrogen monoxide. So no problem with the placement of the atoms. Dalawang klase lang naman yung atoms dito and tig-iisa lang sila. So itatabi mo lang yung dalawa. Nitrogen and oxygen. Total valence electron dito would be an odd number. So that's 5 plus 6, that's 11 electrons. Then you write a single bond minus 2. So that's 9 electrons. So question, between nitrogen and oxygen, since these are all surrounding already, wala namang central dito. Okay, wala talagang central atom. And you know that the surrounding atom, if ever, di ba, pag may central, ang mga surrounding atom are always highly electronegative atom. Na kung saan kapag merong remaining electrons sa mga highly electronegative surrounding atom, di ba? Ide-distribute una. Okay? So question, yung remaining 9 electrons, saan tayo una mag-distribute? Nitrogen or oxygen? Okay, very good. Oxygen. Why? Because between the two, oxygen is more electronegative. Being more electronegative, it will really attract or pull electrons more towards itself. So uunahin natin is stabilize yung oxygen. And at dito sa state na to, kulang siya ng 6 para ma-attain niya yung octet. And ilan na lang yung natira. Nag-distribute ka na ng 6, meron pang 3. From 9, meron pang 3. So by pair yan. 1, 2. So meron talagang isang unpaired electron. Isang unpaired electron. And this is not yet the final Lewis structure. Kasi remember, if ever one of the atom did not attain octet, you can make use of the fifth step. Okay? Make use of the fifth step. And since yung kasama niya is oxygen and oxygen stable number of bonds is 2, pwede pa kayong bumuo ng bonding pair, bond line. Okay? So make use of the fifth step, change the one lone pair into a bonding pair. Okay? So this is one of the Lewis structure ng nitrogen monoxide. And you can check if this is a stable Lewis structure given the idea ng or concept ng formal charge. Okay? No problem with oxygen here kasi oxygen obviously it would really carry no charge, no formal charge because it has already two stable number of bonds. So kahit yung nitrogen na agad, yung i-check nyo, i-confirm if stable na ba yung nitrogen dito or magdadagdag pa tayo ng another bonds. Sige, let's check. Nitrogen's valence electron, 5. Minus, meron ba siyang lone electron? Yes, 1, 2, 3. Plus, meron ba siyang bonds? Yes, 2. What is the charge? Wala din siyang charge dito. So this is stable binding state of the two atoms in the molecule nitrogen monoxide. Okay? Now, if you wanted to extract the other resonance structure of nitrogen monoxide, pwede din naman kasi meron naman talaga siyang resonance structure, isang resonance structure. Okay? So let me extract the other resonance structure. 'Di ba kanina una tayong nag-distribute ng 9 electrons. Yung 9 electrons una nating dinistribute sa oxygen, which is yun yung tama. Okay? But if you are asked sa question for the resonance structure of nitrogen monoxide, then you have to provide all the possible Lewis structures ng nitrogen monoxide. So pwede din naman, una tayong mag-distribute ng 6 na electrons kay nitrogen, but you will really expect na upon determining the formal charge, this is not the stable structure. Okay? But if ang question naman is you have to draw the resonance structure of this molecule, then you have no choice but to provide all its Lewis structure. Okay? But if you are asked naman to draw only the stable, the most contributor structure or resonance structure for the resonance hybrid of this molecule, then isa lang yung idodraw mo, yung pinaka-stable niya. Okay? So for the purpose lang na ipakita, i-present yung resonance, another resonance structure ng nitrogen monoxide. So ito po yung isa. So 'di ba you have distributed 6 and then 9 man daw yung remaining. So meron pang tatlo. Okay? So this time see, oxygen yung not yet stable, kinulang. Kumbaga kinulang ng electron. So pwedeng you apply the fifth step, change the lone pair into a bonding pair. Okay? But when you check for the formal charges of each atom in this molecule, in this structure, both have charges. Okay? Hindi po kagaya ng structure 1 na walang charges yung nitrogen and oxygen. Sige, let's try to check. Nitrogen here, again, 5 yung valence niya. Meron siyang 4. 4 yung lone electrons plus meron siyang dalawang bond. So this would carry negative 1. No? Negative 1 yung charge niya dito, negative 1. What about oxygen? Oxygen's formal charge here, di ba 6 yung valence niya, meron siyang lone electron, 1, 2, 3. Meron ba siyang bonds? Yes. So 6 minus 5, so that's positive 1. So you can check here that several non-zero formal charges are observed. Several non-zero formal charges observed in this structure. So this is not preferable based on the criteria, di ba? In choosing for the more important contributor to the resonance hybrid. Okay, so this is not in stable binding state. Okay, sige. So again, these are examples of molecules with an odd electron atom. Merong unpaired. Merong unpaired electron on its structure. Okay, sige. Let's have the last exception to the octet. They occur among molecules with expanded valence shell. So basically, most of the molecules that are exception to the octet is ito, yung merong property nila. The central atom is capable to expand. Again, the central atom, there are few central atoms capable to expand. Okay? Especially those central atoms found in period 3 or higher. When I say period 3 or higher, so period 4, 5, 6. Okay, higher than period 3, so period 4, 5, 6, 7, etc. Kasi again, period 3 or higher, they already contain D subshells that are empty. D subshells that are empty. So that's the reason they could expand their valence shell, because they have empty D subshells. They can hold additional pair of electrons, which is more than octet, more than 8 electrons. So I repeat, kapag expanded valence shell, makikita nyo sa molecules, yung central atom contains more than 8 valence electron. Okay, and again, Usually, the central atoms are those found in the period 3. Yung mga non-metals particularly, halimbawa, pinaka-common, si sulfur, phosphorus. When you check it on the periodic table, they are found on the period 3. Okay, another example, xenon, iodine. They are found in the period 3, then higher. Pwedeng sa period 4, 5, etc. Because again, they're capable to expand because they have empty d subshells. When you write their, kumbaga, when you write their electronic configuration, may mga d orbitals sila. D orbitals nga empty. And that's the reason pwede silang mag-hold ng additional pair of electrons. Okay, so I hope that is clear. So let's have an example of molecules, species with a central atom that is capable to expand, meaning more than 8 electrons yung surrounding valences nila upon writing their Lewis structure. Let's say, for example, phosphorus. Again, phosphorus in the periodic table, try to look at in the periodic table. It's found in period 3. So you'll expect na it would really have an empty d orbitals, and therefore it's capable to expand. Now, although sa phosphorus trichloride, this is phosphorus trichloride versus phosphorus pentachloride. Siyempre, sa phosphorus, i-compare muna natin yung dalawa. So, phosphorus trichloride, syempre, tatlo lang naman, di ba? Yung chlorine dyan. So, you would expect na the phosphorus here can attain octet. Yes, can attain octet. Knowing na tatlo lang naman yung surrounding niya. Surrounding na, kumbaga, atoms. Okay, sige. Draw natin ha, bakit na-attain niya yung octet. Draw natin yung Lewis structure niya. Sige, so valence electron ng phosphorus is 5 plus 7 times 3. Sige, you tell me what is the total valence. Sige. Okay, 26 electrons. So magdodraw ka pa 'di ba ng bonds. Single bonds per single bond. So anim lahat minus 6, so 20 electrons. So yung 20 electrons remaining will be distributed first sa surrounding chlorine. So tiga-anim yung chlorine. So 6, 12, 18. 18 na yan. 20 man. So meron pang dalawa. So yung dalawa, kay central phosphorus yan. No problem. All of them attain octet. All of them attain octet. So phosphorus may attain octet. Depende yan sa surrounding atoms niya. Okay? But pwede na din naman in some cases, phosphorus could expand its valence shell. Pwedeng more than 8. More than 8 yung surrounding niya na electrons. Well, in this case ha, octet yung phosphorus. What about in the case of phosphorus pentachloride? Obviously, ilan yung surrounding? 5. Tingnan natin ha, phosphorus. 5 daw yung surrounding chlorine. 5 yung surrounding chlorine. Therefore, we would expect that it would really form 5 bonds. And ilan ba yung equivalent kapag 5 surrounding bonds? Ilan yung equivalent electrons? 5 surrounding bonds, that's equivalent to 10 electrons. Diba? So, atong i-check ha. Sorry. Ayan. Check natin yung valence. Ikumpletuhin natin yung Lewis structure niya. So, again, the valence of phosphorus is 5 plus chlorine has 7 times 5. That is, sige, you tell me, 40. Minus pa, 40 lang ba? Okay, minus 10. Yeah. 40 minus 10, 30. So, yung 30 electrons will be distributed by 6 to each chlorine. So, ubos yung 30. 6, 12, 18, 24, 30. Okay? Then you can check for the formal charge of phosphorus if it really attains octet at that state. Phosphorus na agad yung i-check nyo na formal charge. Kasi alam nyo naman, di ba, na kapag mga halogens, isa lang talaga yung bonds nila with 6 lone electrons. Stable na sila on that state. Sige, si phosphorus. Phosphorus has 5. Valence electron, meron ba siyang lone pair dyan? Wala. Meron ba siyang bonds? Yes, 5. Yung surrounding bonds ni phosphorus in this molecule. So it would carry no charge. And yan yung stable. Isa din yan sa stable binding state ng phosphorus, having 5 surrounding covalent bonds. 'Di ba? So, ang point dito is si phosphorus having an empty d orbitals in its third shell, we can tell nga it is capable of expanding its valence shell. So, more than 8 yung surrounding electrons. It's exception to the rule. Okay, sige, let's have another example. Ito lang din yon. Yung phosphorus trichloride, it attain octet, yung phosphorus, central phosphorus attain octet, but what if it is reacted to another chlorine gas, to a chlorine gas? So you would have additional bonds to 2 more chlorines. Okay, that's why you will form phosphorus pentachloride. Now, let's have another example. Let's say sulfur hexafluoride. Okay, sulfur hexafluoride, sulfur would be the central atom here. And you can see here there are 6. Ayan, 6 fluorine surrounding sulfur. Let's total the valence. Sulfur has 6 plus 6 valence plus 7 times 6 total. What's the total? Valence electron. 7 times 6 plus 6, that is 40. Sige. Yes, 48 electrons. Minus pa yan, minus 12. Okay, so that is 30. Minus 12. Sige, minus 12. 36. Okay, 36 electrons. So yung 36 electrons will be distributed by 6 for each fluorine, for each surrounding fluorine. So having this representation sa structure, ang mga surrounding fluorine, being a halogen, meron na silang isang bond and 6 lone electrons. Stable sila on that state. So they would really carry no charge here, ang mga fluorine. What about sulfur? Ilan yung surrounding electrons ni sulfur dito? Surrounding electrons. Electrons. That is total of 12. No? Electrons. Kasi 6 yung bond. So 12 electrons. And that is exception to the octet. Kasi yung octet dapat 8 lang, 'di ba? Yung surrounding ng mga electrons sa atom. Okay, so dito 12 electrons. So pwede din si sulfur, possible na si sulfur pwede siyang mag-expand. Okay? Kasi pasok siya sa criteria of those central atom capable of expanding their valence shell. And then you can check the formal charge. Pwede natin i-check yung formal charge. If sulfur will carry no charge on that state, or stable ba siya on that, stable with that number of bonds, 6 number of bonds. So sulfur has 6 valence. Wala siyang lone pair, 'di ba? Wala siyang surrounding lone pair diyan. Meron lang siyang 6 na bonds. Okay? Always remember the formula in determining the formal charge para hindi kayo malito. So 6 minus 6 is 0, stable binding state niya ni sulfur having 6 surrounding covalent bonds. Okay? And these are other examples. So let me erase this part. Ayan. So hindi ko na siya individually i-draw. Yung point lang talaga dito is that the central atom, if you try to check, when you draw this, inyo siyang step by step og draw yung Lewis structure nila, you will realize na yung central atom expanded their valence shell having more than 8 electrons surrounding the central atom, surrounding them, being the central atom. Si iodine, ilan yung surrounding electrons niya dito? Sige, you tell me. Surrounding electrons ni iodine. That is, okay, that's 12 electrons. What about xenon here? How many surrounding electrons? Okay, it's also 12 electrons. Okay, sige. Let's have another example. Before I proceed, let me excuse for a while, ha. Let me take my personal necessity for a while. 1 minute. Okay, let's resume. Let's have the sulfuric acid naman. Okay. In this molecule, you will also observe that a central atom will contain more than 8 electrons surrounding it. Okay, sige. Step by step na to yung pag-draw ng Lewis structure niya, ha? So, given this molecule, chemical formula rather, of course, we would realize nga hydrogen will never be a central atom here. Okay? So, obviously, sulfur, between sulfur and oxygen, si sulfur yung magiging central dito. Okay? Now, kung si sulfur yung magiging central, sino yung kasunod probably na magiging surrounding niya? Of course, that would be oxygen. Listen, when you are to decide placement of the atoms, having the central, and then sino yung magiging surrounding, if you encounter molecules with many, kung based on quantity bitaw, based on quantity, marami yung magiging surrounding atoms niya, then different types of atoms. Kasi this time may oxygen as the surrounding, meron ding hydrogen as the surrounding. So, kumbaga dalawang klase ng atoms surrounding sila. How will you decide kung directly attached ba sila sa central atom or they are not directly attached? So, this is how we will do it. You have to um, decide based on the electronegativity property nila. Okay? So let's start with, diba, sulfur being the central. So you are sure nga si sulfur central yan. And you all know that between oxygen and hydrogen, oxygen is highly electronegative. And how many oxygen are there present in this molecule? There are 4, diba? So kapag ang highly electronegative surrounding atom is total of 4 or more than 4, always take note that they are the only surrounding, directly surrounding atom to that central atom. Okay, sulfur. I repeat, kapag sa isang molecule, isang chemical formula, may kasamang hydrogen. Isa si hydrogen sa pagpipilian nga external, surrounding siya na atom. Tapos meron siyang kasama na highly electronegative atom. Example, in this case, si oxygen, highly electronegative man siya. Ensure man mo nga si oxygen is, it's a surrounding here, surrounding ng central sulfur. And when you check the quantity kung pila ka buok ang surrounding electronegative atom, okay, comparing to hydrogen, it is 4 or more. If it is 4 or more electronegative surrounding, we're talking about surrounding atom, ha? And they are electronegative. Take note that this four or more electronegative atom should be the ones that are directly attached to the central. Okay? So, yung hydrogen dito should be the superficial good na mga atom. Superficial meaning talagang nasa sa pinaka-external or pinakalabas ng molecule. So, pwedeng, since apat man yung sides na to, may sides dito, another side, this side. Yan yung pinaka-external sides ng molecule na to. And dalawa lang naman daw yung oxygen. Dalawa lang yung oxygen. So, pili ka lang on what sides mo ilalagay yung dalawang oxygen. Okay? Pili ka lang saang oxygens mo ilalagay yung tig-iisang hydrogen. So, since dalawa lang yan, so pwedeng left and right ng oxygen. Left and right ng oxygen. So, let me draw it. So you have one hydrogen here, very external nga hydrogen, another very external nga hydrogen. Okay, so that's how you decide. How you decide for the placement of the atom? Let me repeat para mas klaro. If you encounter chemical formulas na may kasamang hydrogen and pagpipilian mo siya kung um, meron kang pagpipilian ba? Kasi meron siyang kasamang ibang atom being also a surrounding atom. Okay? So if that happens, may hydrogen tapos meron siyang kasamang different different class, different type of atoms na magiging surrounding din, you check kung ilan yung quantity ng highly electronegative atom na yan being the surrounding. If it is 4 or more, yung apat na yan or more of that electronegative atom, sila lang po yung directly attached to the central. Yung hydrogen automatically will be the most superficial, pinaka-external atom. Okay? So this is the best arrangement for the atoms in this given example, sulfuric acid. Sige, let's proceed to the second step in writing the Lewis structure. Di ba, with total the valence. 1 times 2 plus 6 plus 6 times 4. Oh, you tell me what is the total? 6 times 4 plus 6 plus 2. Okay, that's 32 electrons. Minus, naguhit na ako ng ilan ba yan na bonds? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that's minus 12. Electrons, yes, 20 electrons na lang. Saan natin ilalagay yung 20 electrons first? Sa mga surrounding oxygens. So 1, 2, kulay pula na lang para mas klaro. 1, 2, 3, 4, 5, 6. Sa surrounding palagi, magsisimula, mag-distribute. So, kulang ng 6 yung nasa taas, ganun din. Sa baba, kulang ng 6. So, 12 na yan, 6, 12. Sino pa yung kinulang? Another oxygen on the side, kulang ng 4. Then, yung last 4, totaling 20, total of 20, sa kabila naman on the left. Okay? Now, when you check for all the atoms, in this given molecule, all of them attain octet. Except, of course, for hydrogen. Kasi, di ba, exception man talaga yan. Kasi, dalawa lang talaga dapat yung surrounding electrons for a stable state of hydrogen. Meaning, all of them already attains octet, especially for oxygens and sulfur. Okay? But, when you check for the formal charges, i-check natin yung formal charges nila. Yung talagang obvious na meron talagang charge. Si oxygen dito, ibang kulay na lang, ayan. Oxygens, no charge naman ito. Ganon din sa dalawang left and right oxygen. Left and right oxygen, meron naman silang dalawang bonds. Remember, if dalawang bonds ang surrounding sa oxygen, they will not carry charge. That is the most stable number of bonds for that oxygen. Ano sabi natin kanina kapag isa yung bond carried by oxygen? Ano yung charge ulit? That's negative 1. Di ba? Negative 1. So that's a charge, no? And remember, kapag it carries a charge, di ba, hindi yan preferable talaga for a particular atom kasi it already contains a charge. What about sulfur here? Sige, sulat natin. Sulfur formal charge, di ba 6 yung valence niya. Wala siyang lone electron dyan. Then 4. Ano yung formal charge? Positive 2. Diba? Positive 2. And it's very large. Remember when we discuss for the criteria in choosing the contributor or most important structure, diba hindi preferable kapag mayroong larger? I hope you can still remember. Kapag may larger nga formal charge, that is not preferable. So meaning to say, this is not yet the most stable structure niya. Okay. So meaning to say, we could expand. Remember that sulfur could expand its valence shell. Okay? So pwede natin kunin, i-apply yung fifth step, no, para ma-attain nila yung pinaka most stable state nila. So para mag-expand si sulfur dito, you can make use of the one lone pair from the oxygen on top, make it a bonding pair. Another lone pair naman, at the bottom, oxygen, gagawin mo siyang bonding pair. Let's try to compute again further formal charges. You try to check all the oxygens both on top and at the bottom. Di ba meron na silang dalawang bonds. And then 4 lone electrons. Dalawang bonds for this oxygen and then lone electrons apat. So meaning to say, this will not carry charge anymore. Tama? Kasi meron na siyang dalawang bonds. What about sulfur here? This time, upon expanding its number of covalent bonds. So sulfur again has 6 valence. Okay, very good. Wala siyang lone pair. And ilan yung bonds surrounding it? Sulfur, 1, 2, 3, 4, then 5, 6. Meron siyang 6 na bonds. So that's 0, making its formal charge 0. So meaning to say, ito yung pinaka-stable Lewis structure ng sulfuric acid. Kasi maa-attain nila yung pinaka-stable binding state nila. Okay? You do the same with the other. Ganun lang din po yung nangyari din sa other example. Na-erase na. Dili na nako tumabalik. Na-erase na ko siya. But anyways, recorded nandun siya. Sorry for that. Okay? Sige, so eto din, gawin nyo siya sa phosphate ion. And take note, kapag nag-draw kayo ng Lewis structure, kapag ion, place it inside a bracket, square bracket, then the charge outside. Yung point lang dito yung point dito is nag-expand yung number of bonds, yung valence shell ng central atom. Ilan na yung surrounding electrons ng phosphorus dito? Electrons, surrounding electrons. That's a total of 10, di ba? That's a total of 10 electrons. Very good. So it's exception to the octet. So that's the point of this topic. Discussing those Lewis structure that are exception to the octet. So one exception, we have yung letter A, we have electron deficient atom, kinulang, kinulang sila less than or fewer than 8, yung surrounding electrons sa central. Letter B, may odd electron atoms. Ito, letter C, which is most commonly encountered. Ito yung marami talaga. No, kapag exception to the octet, pinakamarami yung merong molecules na nag-e-expand yung central atom nila. Okay? Sige. So you try this also during your independent study time. Ayan. Try this. And sige, i-apply natin again yung pag-determine placement. Kasi kahit yung placement lang yung ng atoms. Example number 1. Diba, it looks like sulfuric acid. Diba? Sulfuric acid H2SO4. Sabi natin, si sulfur dito would be the central atom. Dito naman, i-apply natin kay phosphoric acid. What do you think is the central atom here? Phosphoric acid. Okay, very good. It's very obvious. Phosphorus will be sa central atom here. Ano sabi ko kanina? Kapag meron sa chemical formula, may kasama si hydrogen, being the surrounding atom, meron siyang kasamang highly electronegative atom na magiging surrounding din. And then, yung quantity is 4. Yung highly electronegative atom, 4 siya or more than. Okay, more than 4. Automatic, yun lang pong highly electronegative atom, yung directly attached kay central. Yung hydrogen na yan, siya talaga yung pinaka-external. Hindi siya directly attached sa central. Okay? That is applicable only kapag kay hydrogen ha, na meron siyang kasamang surrounding atom na highly electronegative. And it is total of 4. Total of 4 or more. Okay? So, yan yung magiging arrangement. Surrounding talaga. So, it's up to you. Pwedeng sa gilid, nasa taas yung isang hydrogen. Okay? Depende sa, basta naka-attach si hydrogen, tig-iisang hydrogen sa mga external oxygen. Now, let me give you example like, for instance, etong, in this example, H2CO. This time, ganun din. Si hydrogen, meron din siyang kasamang highly electronegative atom. Pero tingnan, ilan lang yung oxygen? Ilan lang yung oxygen dito? 'Di ba isa lang? Hindi naman apat. Isa lang po yung oxygen dito. So you will conclude na si hydrogen is directly attached to the central atom. Kasi isa lang naman yung highly electronegative atom being a surrounding atom. Okay? Pero kapag naging apat na yan or more, na kasama ni hydrogen na pagpipilian mo bilang surrounding, that's the time na you decide hydrogen cannot be directly attached to the central atom. Okay, I hope that is clear. Sige. Ito, sa number 2, wala namang hydrogen, di ba? Walang hydrogen. So, automatic, when you decide for the placement, the central atom would be boron. Obviously, it's boron, di ba? Kasi fluorine and chlorine are highly electronegative atom. So, it's up to you what is the arrangement of the surrounding, nasaan yung chlorine, nasaan yung fluorine, basta sila ay mga surrounding, directly attached to the central boron. What about number 3? Meron bang hydrogen sa number 3? Obviously, wala. No, wala. Walang hydrogen. So, wag ka nang ma-confuse. Automatic lahat ng surrounding dyan ng mga highly electronegative atom directly attached kay phosphorus. Yes, directly attached sila kay phosphorus. Apat na chlorine, and then isang oxygen. I hope that's clear. Okay? Applicable lang yung kanina kapag may kasama si hydrogen, naa si hydrogen sa chemical formula and meron siyang kasamang highly electronegative atom na na 4 or more than 4 yung quantity. Talagang hindi directly attached si hydrogen sa central. Ito, wala namang hydrogen. Yung mga surrounding atom, mga electronegative atom man. So lahat sila directly attached to the central atom. Sige. Or do you have any question? Do you have any question? Section